Hello children, welcome to channel Sube. Children, today I am going to discuss question number 41 from the MCQ part of 2022-23 Physics new syllabus paper. 3 circuit diagrams constructed using 12 resistors are shown in figures. What is the correct relationship of the currents IA, IB and IC flowing in the circuits respectively? So there are 3 diagrams. So children, this circuit normally we solve in classes as exercises. I don't know whether you have done it. In most classes these things we do as exercises. So let us first try to solve this diagram. So from the positive side of the battery, this wire is coming and it is divided into 3 resistors at the beginning like this. It goes to 3 resistors, the current goes to 3 resistors, and from the negative wire current is leaving like this from 3 resistors like this, come to these resistors from the positive and then go to this negative wire. So in between these red and blue resistors there are 6 other resistors. I draw them in green color. Red to blue, red to blue, red to blue. So watch them. So observe this structure carefully. From this red resistor, the current divided into 2 parts that are going along this green resistors into 2 parts, divided into 2 parts. As soon as it leaves the red resistor, it goes to divide into 2 parts like this, and here also divides into this green one I haven't marked, so like this. So from the red resistor the current divides into 2 parts. So we can now draw it like this. The red wire like this, and it divides into 3 branches, and there are 3 red resistors, and then from the negative wire it divides into 3 branches like this, and through those 3 resistors then what happens? Let us start again from red one. Red one divides into 2 green lines like this. At the end of the red one the current goes to 2 branches that are marked in green color, and there are 2 resistors like this in each. So we are simplifying this circuit. So from the blue resistors, from the end of these blue resistors also there are 2 resistors in green color, divides into 2 branches, divides into 2 branches, divides into 2 branches, so like this. So this blue wire also divides into 2 branches and connect to the previous resistors like this. So this is the simplified diagram. So you should be able to simplify the diagram like this. Because I used colors, then I think it is easier for you to understand, otherwise it will not be easy. So now from the battery connection like this, I have turned the circuit so that it is easier to understand. 90 degrees I have rotated. So now the current from this positive side flows through these 3 resistors, and suppose now we are here. So the difficultness is same in all these 3 paths. It is useless jumping from here to here or from here to here expecting a easy path. There's no any easy path. Whatever the path you follow, the difficultness is same. Already we have followed one resistor, and this one also have already followed one resistor, and this one also have come through one resistor, and it has to go through these 2 resistors and this one resistor, and the one coming along this line also has to go along these 2 resistors and through this one resistor, and the one is coming along this line has to go through this resistor and through this resistor. So the path already that has come, that has followed, is same for these 3 lines, and also the path that has to be go is also same whatever the line you have come. So therefore the difficultness is same here, and also the same fate here. The difficultness is same here also. If someone has come to this place already, the path it has passed is same whatever the line. There are 3 lines here, so the path he has to follow is also same in these 3 lines. So therefore at these points the difficultness is same. It has to go furthermore along this one resistor. It has already come along these resistors. Along these resistors, all these 3 paths are same. Same difficultness is there in these all 3 paths. So therefore this junction, and this junction has the same difficultness. Difficultness means voltage. Voltage is difficult. The potential is, the simple word for potential is difficultness. You don't know that, do you? You know only potential all the time, potential. In simple words, it is the difficultness. We measure by potential. What do we measure? By potential. Taking the potential, we measure the difficultness. So the difficultness is same here. That means the potentials are same. So therefore we can connect. Why we can connect? If we connected, do you jump from here to here? If you come along this line, suppose these are stairs. Suppose these resistors are stairs, so you have to climb down along these stairs, and you will get tired. So do you imagine this path is easier and I should jump to this one? No, you don't jump, because you know even though you followed this new path, the difficultness is same. Therefore you don't jump, you just follow the same path where you came. And also, do you jump from here to here? So there is a path now, a new wire is there, so I can go. Do you jump from here to here? No, because the same fate, even though you came here, there's no any easiness. You have to still follow these steps. So therefore there will be no current even though you connected these junctions, nodes using a wire. There will be no current. Here also the same fate. Even though you connected these nodes using a wire, there will be no current. So if there's no current, you can it doesn't affect the circuit, so you can connect. Since it doesn't affect the circuit, you can connect using a wire. So you don't have to waste a wire, just you can pull these junctions, pull these nodes to a one place and solder it like this, connect it like this. You don't have to waste a wire, however you have to connect, because you can connect because the voltage, the potentials are same. You can connect like this without using extra wires. You can connect to a single node instead of using a line. So here also you can do the same thing without using an extra wire, without using an extra wire, you can just connect these lines using the same wire to a single node, and also you can connect you can pull these wires and connect to a single junction like this. Now what is this structure? It is familiar now. These three are parallel, therefore the resultant is R divided by 2. These 6 are also parallel, so the resultant is R divided by 6. These 3 again are in parallel, R divided by 3. So these 3, what is the relationship? Series, they are in series. Therefore the final equivalent resistance is, you can simplify to a single resistor now. So the value of that is given by how? You have to just add, get the sum, because these are now in series. R divided by 3 plus R divided by 6 plus again R divided by 3. So this is the resultant of this net. So you can write 2 times R divided by 6, this one as it is. Now 2 times R divided by 6, multiplying denominator and numerator by 2. So the common denominator is 6 now. 2, 2, 4, 5. 5 R is the equivalent resistance. So now you can use the equation that we use for simple ideal circuits. This one is a simple ideal circuit. Why? There is only one resistor, there is only one battery, there is a current and also a voltage and internal resistor for the battery. So everything is there, but not complicated. 1, 1, 1, 1. So that is why we called it a simple ideal circuit. So the equation for simple ideal circuit is, E equals I times in brackets R plus R. Simple R is the internal resistance of the cell. So now E is, so you don't have to do these things, because only you have to compare. You don't have to do these things. These things you don't need. Up to this level is enough. So now let us simplify the second one. Let us stop here. The second one now. This circuit let us take, because they have not given these values. So now let us rotate this as the previous one, like this. So what is it? It is equal to the first one. What is this? It is the simplified form of this box resistor. So it is equal to the second diagram they have given. So this one is the same, you see. So we can write here now what? This diagram is equal to this diagram. Now let us take this one. Let us take this one and let us discuss it. Let us rotate this 2 as previous. Now let us simplify this following the same way, using colors. This one red, this one red, and this one red. From the blue line, this one is the negative. This one, the first one we take only, only the first one, only the first resistor we consider. So there are these 3. The direction doesn't matter, however it is connected to this junction. There are 3 blue color resistors, and from the red color resistor there are 2 branches again as previous, and also from the blue resistor, at the end of the blue resistor there are again 2 branches. This one is the end, there are 2 branches like this. So in between those 2 branches there are green color resistors like this. So do you see the same thing, same diagram as previous, same diagram as previous. So we can simplify next time to this one or to this one. So that means this circuit also is equal to this one, and all these three are equal. So if the circuits are equal, the same current must pass through that, and those same current should pass through those all these networks. So therefore the currents should be equal, because the current is they have marked as soon as the battery positive is passed. So this one is the answer. The fifth one is the answer, children. So if you have done these types of things previously, you don't have to do much things. From the first glance you can identify that these three are equal. So now we have solved the problem. The answer is fifth one. So let us check the answer sheet. 41, the answer is 5. So children, let us do now. I think you understood, because I used color. If you used colors, you can get this into your head. So without stopping at this, you have to do the same thing using your own hand and your own color pencils. You should do some work like this as I did, then it will go to your head and head permanently, and it stays there permanently. Otherwise, if you just watch this, okay, yes, correct, and you forget everything soon. You have to do something using your hand and your eyes, then your brain, then only it will stay in your head permanently. Not permanently, for a long time it will stay. If you refer again and again, as we teachers do, we have to do, because we have to teach, so we refer to these things from times to times. So therefore we don't forget, therefore, because when we leave one class, then the next class is coming. So we have to do these things every year, and every 3 months to 3 months, sometimes every 3 months to 3 months. And if we do few what we call these revision classes, we have to do weekly one. So like that, we are in touch with these things, therefore we don't forget normally. So if you do the same thing, you can keep these things in your mind. If you started to teach somebody, some junior friends or students, then it will be benefited for you. It will the things will be in your head. So therefore do that. Find out some junior students and teach them. Then you will get the result. As he, you also will get the results. So let us go to now target questions. Children, I altered the problem. So this one is the target question now. So try to solve it following the pattern that I showed you in the previous problem. Honestly, now pause the video and honestly do it. So as you have paused the video, now I am going to start. So I am not going to explain again. So from the positive battery side, we have 3 resistors. When we simplify it and connect to one point, and also there are 6. So this is the simplified circuit. So previously I explained well, therefore I am not going to do it again. So the circuit is like this after simplifying. So the resistors are there. So the values are now 10 divided by, because each are 10 ohm, 10 divided by 3, here 10 divided by 6, here 10 divided by 3. Altogether the equivalent resistance is 10 divided by 3 plus 10 divided by 6 plus 10 divided by 3, because these are in series now. So what we get, 25 divided by 3 or 50 divided by 6. We can write this as 20 by 6, this one also 20 by 6, then 20, 20, 40, 50. 50 by 6 means 25 by 3 is the final equivalent resistance. So E equals I times in brackets R plus R. This one is 10, I we don't know, 25 by 3 plus simple R is 5 by 3. So altogether here 30 by 3, I 10. So you get 1 ampere. 1 ampere. So the answer is 1 ampere. I haven't copied the answers, but doesn't matter, now I can do it. So the answer is 1 ampere, this one, fourth one. So let us go to the target question number 2. So children, now try to this one. Here is our target question number 2. Simplify this circuit and find out the current. Honestly do it without looking at my answer. Now pause the video. So as you have paused the video, now I am going to start and simplify this circuit first of all. So let us simplify the circuit from the red line. There are 3 resistors. From the blue line there are 3 resistors. In between them there are 6 resistors like this. So the simplified form is three you can connect these lines because the same difficultness or same potential, and also you can connect these lines, these junctions together because same difficultness or same potential. So in between them there are 6. So you get the same answer. You see, 10 divided by 3, 10 divided by 6, 10 divided by 3. Same answer, you don't have to calculate. So the answer is 1 ampere. Fourth one. So here I gave this problem for you to learn how to simplify the circuits. Even though the answer is same, simplify the circuit. And we used this equation. We didn't use this one in the exam MCQ paper, the 41, but we did a little bit earlier. Then that I revised here, and I showed you how to simplify. So children, now the time is over, so let us going to now wind up. So we did the original question, and also we did these 2 target questions. So I think you are happy. Then you have to make me happy too. By how? By subscribing my channel if you haven't subscribed it yet. Not only that, children, please subscribe me using your friends and relations, brother, sister and mother, father. Take your mother's phone and subscribe my channel. Take your father's phone or ask him to subscribe my channel, and so do to these other with these other your relations as well, brother, sister, and your best friend. Ask them to subscribe my channel. Please help me to increase my subscription count. Still I have 670. I have to go to 1000. From May of this year I am uploading daily videos, but still I have 617 subscribes. So if I don't earn a coin, still I have to go to 1000. Then only they will pay me something. So therefore please help me to reach this level, and also share my link among your friends and ask them to subscribe like that. At least if you give me 10 subscriptions from your family, then I might reach this level very soon. So therefore do that, and also do like my channel, like my videos. Then only the YouTube will push them, the videos, to the front. Otherwise they will place at a corner. So that is the system. And also press the bell icon. That will help you. As soon as I uploaded the video, you will get the message. So children, do those things for me as I do for you. See you tomorrow at 6 o'clock in the evening. Goodbye.